video, we're going to be looking at the transformations of sine and cosine functions. The learning intention is for us to explore various transformations applied to the parent sine and cosine functions, to explore circular functions with particular horizontal as well as vertical translations, and to determine the minimum and maximum values for sine and cosine functions. For this particular lesson over here, it's going to be overlapping from what we covered from last lesson. So last lesson, we looked at some of the key characteristics of circular functions, and these included the amplitude, the period, the minimum, maximum, domain, and range. And I did briefly talk about some types of transformations, but I'm going to go into a lot more detail about those transformations in this particular lesson. So hopefully in this lesson, you're going to find that these topics should strengthen and consolidate your understanding. So the very first transformation that we're going to be looking at is dilation. And a dilation is where you change the value of A in the general equation. So for instance, the general equation was something similar to this over here. So if you change the value of A, what you're actually doing is you're going to be making the graph either smaller or larger, okay? Now, when you happen to have a large A value, then you're going to have a very long or elongated graph, because what's actually happening is that you're actually stretching the graph vertically. That's what makes it more larger, and that is also shown by this particular graph over here. Notice that as your A value increases, then you're going to have a more longer graph. In comparison, when you guys actually have a small A value, what essentially happens is that you will get a smaller graph, because the small value makes the graph more compressed vertically, okay? Now, I do also want to mention that last lesson, we also talked about the value of A also describes the distance between the middle or the midline to a peak, okay? And this distance was referred to as the amplitude, okay? And we also talked about the amplitude, because it's a distance, cannot be a negative value. Now, I might have actually said something incorrectly in our last lesson, so I just want to actually correct myself and correct your understanding as well. So in the previous video, I said that the amplitude could be used instead of the word dilation in this particular topic for circular functions, but this is actually not true at all. Although both of these concepts is dependent on the value of A. So what that means is that although dilation amplitude is kind of determined by the value of A, they both measure two different things, and as a result, these words are not interchangeable. So they are not synonymous at all, since they measure different things and they have different definitions. We talked about the amplitude being the distance between the middle and the tallest peak, whereas the dilation is essentially a type of transformation that either stretches or compresses the graph, which therefore ultimately affects the size of the graph. So therefore, two different definitions. The next thing I want to talk about is how do we actually comment when there is a vertical dilation. And in order for you guys to do that, then I want you guys to be using this particular template over here. So in order to use a template, all you really need to do is just substitute the value of A into this little square box over here. Now, you might be wondering, why is it the dilation of factor something something from the x-axis? And the reason why it's moving away from the x-axis is because if you move away, what actually happens is that you are going to be changing the vertical length. Just a reminder that this is the x-axis over here. So if you're going to be moving away from this horizontal line, then you're going to be changing the vertical length of the graph. So let's use one example over here. So in this case, in this example, so if we just concentrate on y is equal to 2 sine x, which is the green graph on the left hand side, if I was to use this template to comment on the dilation, I would say dilation of factor 2 from the x-axis. Or in my next example over here, if I've got a half over here instead, then I'd just say dilation of factor 1/2 from the x-axis. So pretty straightforward. Have a go with answering this question over here. Give yourself 2 minutes, and then we'll go through the answers together. So for question 1 over here, they've given you the equation y is equal to 5/2 sine 2x plus 1. So in this case, this is your A value. So all you need to do is substitute that into the template. You would just say dilation of factor 5/2 from the x-axis. For the second question, it says, compared to the graph y is equal to sine x, which graph would be larger, okay? So in this case over here, you could just compare the a values of the parent function and this function over here. And because 5 and 2 is the same thing as 2.5, and that's a larger value than 1, therefore, this particular graph will be more larger. And you can prove this by putting both of these equations over here on Desmos, which we will therefore graph both of these graphs for you. The next thing I want to talk about is horizontal translation, okay? And this occurs when you actually change the value of c. So any value of c that's not equal to 0 would result in a horizontal translation, shifting the graph either left or right along the x-axis, okay? And I want you guys to think about when we learned about the quadratic formula. Remember that when we change the value inside the bracket over here, then you've got to be moving left or right, and that's just shown on the graphs I have down below. One thing I do want to point out is that remember that we always said that usually the value that's kind of opposite, so the opposite sign in the bracket will indicate which direction you're going to be moving, okay? So therefore, the opposite of positive pi on 2 is negative pi on 2. That's the reason why you're moving this direction, because that's the negative direction, whereas this over here is the positive direction along the x-axis, okay? That's why you're moving this way over here. And similarly over here, if you got a negative sign, the opposite of a negative sign is a positive sign, so therefore you're moving in the positive direction 3 units towards the right. Remember that I did say in our last lesson that we don't actually use the word horizontal translations as often. There is another word where you could use instead, and that just will depend on the textbooks and websites you actually use. But horizontal translation may also be referred to as phase shift, okay? So phase shift just means moving left or right. And when you have a positive phase shift, you're moving to the right-hand side because that's the positive side of the x-axis, whereas when you've got a negative phase shift, then you're going to be moving to the left side or towards the negative region along the x-axis, okay? So in my example over here, in this case, this is opposite, so therefore your phase shift is going to be positive pi on 2, whereas in this case over here, it's going to be the other direction. It's going to be negative pi on 2 instead, which means you're moving the graph towards the left. Have a go with answering these two questions over here and give yourself 2 minutes. So for the very first question, it reads, phase shift means what? In this case over here, phase shift means either moving left or right, so option B. And for question 2, you need to find out what is the phase shift for this particular equation. In this case over here, it's going to be the flipped sign of this value here, so therefore it's going to be negative pi. So that's what your C value equals over here. And because it's negative, that means you're moving towards the left, so your answer is going to be pi units to the left, option C. The next type of translation, the next type of transformation we're going to be looking at is vertical translation, and that's when you're going to be changing the value of D, and this will move the graph, the sinusoidal wave, either up or down along the y-axis, okay? So we also have another word to describe vertical translation. You could either say vertical shift, and that's the most common one, or alternatively you might say up/down shift, okay? So in this case, when you have got a positive vertical shift, that means you're going to be moving up along the y-axis, whereas when you've got a negative vertical shift, that means you're going to be moving downwards, okay? And you can see that by these examples over here. +1 means you're going to be moving 1, whereas -3 means you're going to be moving -3 units down. Have a go with answering these two questions, and then we'll compare our answers together. So if you guys have answered this correctly, for the first question, your answer should be D. And for question 2, what is the vertical shift in the equation? The vertical shift is this value here, hence your correct answer is going to be also option D. So just to summarize about the transformations that we've been looking at, when the number is found inside the bracket, then this means that you've got a horizontal translation. And I did say that the value inside the bracket tells you how many units it's moving in the opposite direction. So in this case, because that's +2, reverse the sign, it means it's -2, and negatives in this direction, meaning that you're going to be moving 2 units towards the left. Whereas in this case, because the +2 is found outside, this indicates that you've got a vertical translation and that you're going to be moving 2 units up from the origin, okay? So what we're going to be looking at now is how do you actually describe transformations. So in order for you guys to actually describe what transformations are present, what I recommend you do is you actually use this acronym here, Dr. T. Remember, this is an acronym where D stands for dilation, R stands for reflection, and T stands for translation. And I want you to describe the transformations in this particular order. And we often do this in year 12 VC, so it's a good habit that you use the same kind of language that I'm using, when I'm going through some of these examples. So for instance, the question might say, if you're starting off this graph over here, what transformations did you have to apply in order to get to this particular equation over here? And the trick is that you want to kind of find out what is the A value, the C value, and D value. So remember, so because this is in the cos graph, this is the general equation over here for the cosine function. So in this case, if you remember, we talked about A tells you like the dilation, as well as the reflection. C tells you the horizontal translation. D tells you the vertical translation. You don't have to worry about B because B tells you what the amplitude is. So look at the values of A, C, and D for both of these equations. And when you compare both of these values over here, when you have a different A, C, or D value, then that would imply that that type of transformation has taken place. So in this case over here, my A value for this one over here is 1, C is equal to 0 because there's no horizontal translation, and there's also no vertical translation. That's why D is equal to 0. In this example over here, my A value is -3, your C value is -pi, and D is equal to +2. So what does this mean? That means you've actually dilated 3 units from the x-axis, so you've stretched the graph, so it should be more bigger. Because this value is a negative, then this also implies that you've reflected along the x-axis as well. Because you've got a negative pi compared to a 0, that means you've moved pi units to the left. And this +2 means that you've shifted the graph 2 units up. So let's go through 2 proper examples over here. So the equation over here is saying what transformations have applied from this to get to this bad boy. And always go talk about dilations first if there's any present, then reflections if present, then you talk about translations, the horizontal and then the vertical. So in this case over here, I can clearly see that there is a dilation. So therefore, the first one is going to be a dilation of factor 2 from the x-axis. That's how you stretch the graph vertically. But I also say that because there's a number inside the bracket, this implies that there is a horizontal translation. Look at just change the sign of this, so therefore it's going to be a negative pi4, meaning that you're going to be moving pi4 towards the left. So therefore I'd say a phase shift of pi4 to the left, so that's one way you could describe it. Or if you want, you could also describe it in another way. You could say it's translated pi4 units in the negative direction along the x-axis. And the second half over here, that's something that we generally use in VCE, but for now, for the purpose of Year 10, you could use this option as well. But you find that when you study other topics and other graphs, they kind of word it in a very similar manner to the second half. So I just want to expose you to 2 different ways of how you could actually express your answers. So for the second question, describe the transformations from y cos x to y is equal to 3 minus cos x minus pi and 2. In this case over here, I can see that there is no dilation because the value of a is still 1, but because it's a negative, then there's a reflection. So the first thing I'm going to comment is a reflection. So it's going to be reflected over the x-axis. I could also see that there is a horizontal translation, a negative pi and 2, flip the sign, will be positive pi and 2, so therefore you're going to be moving pi and 2 units towards the right hand side. So you can say a phase shift of pi and 2 units to the right, that's one way. Or alternatively, you could say translated pi and 2 units in the positive direction along the x-axis. And this +3 means that you're going to be moving the graph 3 units up. So therefore you could write it something like this. Or alternatively, you could say translated 3 units in the positive direction. Okay, so just choose one way of how you'd like to describe it, not both of them. Have a go answering these 2 questions, and then we'll compare our answers together. So for the very first question over here, because the A value is different, that means you've got a dilation. So it's going to be a dilation of factor 3 from the x-axis. And another thing that's different is this -1 over here, that meaning that you're moving 1 unit down. So you'd say a vertical shift of -1 or you could say translated 1 unit down in a negative direction along the y-axis. For the second equation over here, I can see that it's still negative, so that means it hasn't reflected at all, but there is a dilation factor. So therefore, you're going to say a dilation of factor 2 from the x-axis. I also noticed that there is a horizontal translation. So in this case, you're moving pi on 2 units to the right. So you could say, oh, sorry, that shouldn't be this over here. That's incorrect. It's going to be a phase shift of pi on 2 units to the right, or you could say translated pi on 2 units in the positive direction along the x-axis. And this positive 3 indicates that you're going to be moving 3 units up. So that's how you'd answer these two questions over here. Just make sure that you don't have this, because that shouldn't be reflected since both of them are still negative. So the next thing that we're going to be looking at is writing equations when they've given us the types of transformations that have been applied, okay? So in these particular examples over here, they might give you an equation like this, and then they might tell you that some different types of transformations, as you can see over here. In order for you guys to write down what is a new equation following these transformations, simply follow these steps that I've outlined over here. So if there is a dilation, okay, all you really need to do is just add the number in front of sine or cosine, whatever the equation is. If there is a reflection, just chuck in a negative sign in front. If there is a horizontal translation, add c inside the actual brackets. If there's a vertical translation, just add a number found outside of the brackets. Okay, so pretty straightforward stuff. So let's go through this example together. So in this case over here, you're translating 2 units down. 2 units down. So therefore, because you're moving downwards, we know that vertical translation, the number is always found outside. So therefore, it's going to be something like y is equal to half cos x minus 2, okay, and because it's reflected in the x-axis, okay, all I need to do is just chuck a negative sign in front of this bad boy over here. So therefore, my answer is going to be y is equal to negative half cos x minus 2. Let's go through one more example over here. So for this particular example, it's saying that you've translated 4 units to the right and you've translated 5 units down. So because there's a horizontal translation, we know that that number should be found inside the bracket. But I want to show you what is a common mistake that students would often make for this particular example over here. Because in this example, it's a bit different because you've got a coefficient in front of x. That's the value of b. So in this case over here, many students would often write their answer as this. They might write it as y is equal to 4 sine 2x minus 4. Okay, it's minus 4 because you're moving in the positive direction. Okay, it's opposite. And the reason why this answer is incorrect is because it's not written really in the general form at all. So remember, the general form is this: y is equal to a sine b bracket x. That should be minus c plus d, okay? And in this case over here, what they've done is that in the general formula, they've taken b as the highest common factor outside of the bracket, okay? So therefore, if you were to take out the highest factor over here, this would be y is equal to 4 sine 2 brackets x minus 2. And when it's written in this form over here, which is the correct form now, this implies that you've actually moved 2 units to the right instead of moving 4 units to the right, okay? So therefore, this is not how you should be writing the answer. Instead, you should have taken out the 2 instead. And so therefore, your answer should be like this: 4 is equal to sine 2x minus 4, and now you just continue on. Translation 5 units down, so that number should be found outside, so therefore there should be a negative 5 here. So hence, this is your answer, okay? This is a more of a challenging question. You don't really see these types of questions in Year 10, but I just want to get you guys prepared and ready for Year 11 and Year 12 maths. Have a go at answering this question, and then we'll compare our answers after 1 minute. If you guys have answered this one correctly, in this case, let's do this one first, reflected, because you're trying to follow, Dr. T. So reflection first. So therefore, because it's a reflection, 2 negatives will therefore make a positive. So it will be y is equal to positive cos 3x over here. You've translated pi on 2 units to the left. So therefore, you'd write it as y is equal to cos 3 bracket x plus pi on 2. Okay, and in this case, you're going to be moving 2 units up, so make sure you add a 2 outside. So therefore, this is going to be your final answer. And for the very last topic that we're going to be looking at, we're going to be looking at minimum and maximum values. I know that we've already covered this particular topic in the last video, but because I went through more detail of vertical translations in this particular lesson, that's the reason why I want to quickly revisit this particular topic. So we talked about the minimum value being the smallest y value and the maximum value being the largest y value. And generally speaking, when there is no vertical translation as shown over here, there's no d value, in this case, your minimum and maximum value is going to be the negative and positive of your amplitude, okay? However, when there is a vertical translation, then this is not going to be the case at all. But when you guys do encounter questions where there is vertical translations, I did told you guys that you need to be using these formulas over here to calculate what is the minimum and what is the maximum value. So in these particular formulas, all you really need to do is find out what is the dilation factor or what is the amplitude and what is the translation, the number of units you're going to be moving up and down the y-axis. In this case over here, the value of A is equal to 1 and the value of D in this case is equal to positive 1. So just substitute it into this particular equation over here. So to find out the minimum, take out the negative of the amplitude. So it'll be -1 plus 1. Therefore, minimum value is 0. And that can be shown up here, the lowest y value. And for the maximum value, it's going to be +1 plus 1. And in this case over here, that's equal to +2. And we can clearly see that over here as well. Have a go at answering these two questions, and then we'll go through the answers together. So for the very first question, what is the minimum value? In this case, if you use the formula, minimum is equal to -a plus d. Negative a is going to be -2 minus 2. Therefore, your minimum value is equal to -4. Hence, d is the correct answer. You're trying to find the maximum value for question 2. That is equal to +a plus d. A is equal to +3. D is equal to +1. Hence, d is the correct answer, +4. So that's pretty much all the content that we need to go through. I'd like you to please answer the questions found in topic 5. So these questions can be found on Google Classroom. So answer questions 1 all the way to question 6. This is the end of today's video. Hopefully you found this video helpful. I'll see you guys again in the next video. Bye.